Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about a urea derivative, and the question in front of you, what is the major product of this reaction? I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you'll get the right answer with proper mechanism. Now, I believe you have tried, so it's my turn to give you the right answer. If you look at this molecule is actually an urea derivative, okay, and in this molecule there are two types of functional group. First is this is NH2 amine and this is hydrazine. Now in case of urea, you should know one specific concept, that is this urea is actually a carbonyl group. So if it's attached to one NH2, then what you can expect, that this NH2 lone pair could be in conjugation with this carbonyl. So it is expected to have a resonance, means this is the NH2, this nitrogen having a positive charge, double bond, oxygen is negative charge, other part is this. It means, what message is given by this? That the lone pair of electrons density on this adjacent nitrogen is lesser because of this carbonyl group, means conjugation. So similar phenomena is also possible for this nitrogen, it's true. Same. So these both nitrogens lone pair is involved in the resonance or conjugation with this carbonyl group, but there is another lone pair of electron here which is not in conjugation, point number one. And second, see these two lone pair, this 1 and 2, these two lone pair have significant amount of repulsion because they are adjacent together, and this is called alpha effect. And because of this alpha effect, this nitrogen lone pair is actually, this nitrogen atom is more nucleophilic. Okay, so based on this concept you can understand it's more nucleophilic, reactive, activated, so it will react. And the other part is an aldehyde, which is student electron deficient. Okay, so let's learn how the reaction is happening. This aldehyde is electrophilic in nature because first of all this is attached to electronegative oxygen atom, and second it is aldehyde, means one side is hydrogen, so it's less bulky. So according to Burji-Dunich trajectory or Barye-Dunich trajectory, aldehydes are far more activated for nucleophilic addition. I've already discussed a dedicated lecture on this Burji-Dunich trajectory. So it will attack here and it will open up. Fine. So it is actually addition reaction first and later on water elimination. So this is first addition reaction, second is water elimination to get this imine. And by the way, there is another very good technique, that is a Schiff base chemistry. This is actually Schiff base imine. So there is a very easy tricks is that first you, in this case you remove these two hydrogen and this you remove as water. So water elimination will happen, and ultimately just connect this carbon and nitrogen through a double bond. So in this way you can get the imine. By the way, I have already discussed a dedicated lecture on Schiff base. For better understanding you may visit. So this is the product, but in this context, as I told, this alpha effect, what is this? This alpha effect refers the increased nucleophilicity of an atom due to the presence of adjacent alpha atom having lone pair of electron. Just some time before I told that these two lone pair repulsion, not only this is actually hydroxylamine derivative. Here alpha effect is observed, but which part is going to form this Schiff base? Obviously this nitrogen, not oxygen. Okay, so this is the understanding about this alpha effect. So what is the answer? Answer of this problem is option B, because it will react. So ultimately option B is the right answer. Now question, if this question given you less than 30 seconds, how can you come to the right answer? First of all, you can understand that amines are given, so, and one side is aldehyde, so simple imine formation or Schiff base formation. Fine. Now who is more active? Obviously hydrazines are more active compared to simple amine. Not only that, in this case this nitrogen lone pair is in conjugation with this carbonyl, so it is less active, whereas this NH2 is more active. And third logic is this two hydrogen from here, one oxygen from here, leave as water, and ultimately make a double bond between this nitrogen and carbon. So this is a very easy. So this is the answer. So, and if you don't understand that much, simple that these nitrogen lone pair are not available, so these option 1, option 2 gone, and finally it's hydrolysis. Did I give any water, alkali, acid? Nothing. So this is not possible. So what is left? Option B. So this is the right answer. So this is based on your common sense or understanding, you can come to the right answer also. So in conclusion, what you have learned today, that hydrazine is actually a better nucleophile than amine due to alpha effect, and Schiff based condensation of imine formation is actually a dehydration reaction, and it's very easier for aldehydes. Okay, and urea is highly nitrogen rich organic compounds, and it is the most widely used synthetic nitrogen fertilizer. Okay, and the lone pair of nitrogen adjacent to carbonyl group is relatively lesser available due to the conjugation with this carbonyl group, and aldehydes are more reactive for nucleophilic addition compared to ketone due to the Burgi-Dunich trajectory or Burgi-Dunich principle. And finally, the final product is highly stable due to extended conjugation. What do I mean? See, these nitrogen lone pair, these is single long conjugation possible, and not only that, this is a phenyl group, it is also a conjugated system. So this is the end of discussion. I believe this video may be useful. If you consider my content is worthy, then please help this channel to grow, and if possible, please visit my another channel where I upload global warming and climate change related videos.